All right, moving on to 8.3.4, and it's titled, How Many Triangles Can I Make? It says triangles are important shapes. They are the basic building blocks of many architectural designs and structural supports. A tripod stool will tend to be more stable than a chair with 4 legs. This is because of triangles. So in the last lesson, we became familiar with this e-tool for building shapes and gained some basic information about angles and triangles and quadrilaterals. Today you'll do more in-depth investigation of triangles. We'll learn about when a triangle can and cannot be made, and we'll discover the necessary condition to create a unique triangle. So 891 is our first problem. It says, how many different parts does a triangle have that can be specified or measured? What are these parts? Well, I was thinking to myself, well, a triangle has 3 sides and a triangle has 3 angles. And I also put that the angles are equal to, the 3 angles have to add up to equal 180, but you don't have to put that. So the 3 angles and the 3 sides are the parts of a triangle. Pretty simple for that first one. All right, for 892. It says, how many different triangles do you think you can make specifying only 2 measures to use for the triangle's parts, such as 1 angle and 1 side, 2 angles or 2 sides? It wants us to use the e-tool, which I think will be helpful instead of the resource page this time. Each person will attempt to build a triangle with the specified angle measures and or side lengths listed below without looking at their partner's drawing. Obviously, we can't really do this, because we're kind of by ourselves at our houses, so we're going to do the best we can. We are going to compare the triangles that we built and decide whether they're the same or not. So I'm actually going to build 2 triangles and try to make them different given the conditions that it gives us. Okay, so let's start with this first one. So it says part A, 1 side length of 4.5 centimeters and 1 angle of 135 degrees. So let me open up the e-tool. And I'm gonna be doing this one-handed, so here we go. All right, side length was, oh my gosh, I already forgot. Why doesn't it tell us? 4.5, and 1 angle is 135. So let's make the 4.5 side first. So let's make this 4.5, there we go. All right, now I need an angle. So here's angle A, B, and C. One of those needs to be 135. So I'm gonna make this one, let's try B. If I move it in, it gets bigger. So let's see. Oof. It's gonna be really skinny triangle here. All right, I'm almost there. I'm almost at 135. There we go. Okay, so I have a 135 degree angle here and a 4.5 centimeter side length. So I sketched that on my paper, which it was a very similar triangle to what I made last week when I was making the lesson. So go ahead and sketch that triangle on your paper. You can pause it because we are going to try to make a different triangle from the same conditions. So let's make a different side 4.5 for our second triangle. Let's make this side 4.5. Oh, right. There we go. Let's make angle C 135 this time. So let's go down like this. Almost there. Angle C 135. A little bit small, a little bit bigger. I'm not going to get it exact, but I'll be very close. Ah! Oh my gosh. There, that's as good as I can get. So let's say angle C is 135. So if you sketch that on your paper, you will notice that it's different from the last triangle. So go ahead and pause it and sketch it. And we can conclude that the triangles that we drew, so say I'm both partners in one, we both drew different triangles for part A. All right. So let's try part B. So let's make 2 triangles. For first one, it's gonna have a 60 degree angle and a 90 degree angle. So let's try that out. So let's make a 60 degree angle. So I'm gonna look over here. So I'm gonna look, maybe I'll make A 60. So if I bring it out like this a little bit, it's gonna get smaller there, right there. 60.1, close enough. Okay, so let's make a 90-degree angle. Be careful though, because when we do this, it tends to make that one smaller. Angle C is about 90, but then we made A small, so let's try to fix that. That needs to be bigger. Getting there, almost there. Come on, come on, come on. There. Oh, I'm very close. Super duper duper close. Okay, that's close enough. So that angle C is about 90 degrees, angle A is about 60 degrees, and angle B is 30.8 degrees. So sketch that on your paper. That's our triangle 1. So let's make a triangle 2 and see what it looks like. Let's see. Let's make angle B the 90-degree angle this time. Angle B is 90. Right there. And angle A is 51. Let's try to make angle C 60. Let's see. Getting there. Oh, angle B changed. I gotta move it up. Getting closer, getting closer. Oh. Okay, that's about as close as I'm gonna get. So angle B. Ah, darn it. I tried to be more precise. So angle C is about 60 and angle B is about 90. So then angle A is 30.3. You'll notice this triangle looks different from the other one. It looks a bit smaller, but they are different. So that created 2 different triangles for part B. Let's try part C. It's giving us 2 side lengths, so a 4.5 centimeters and a 7 centimeter side length. So let's see what happens here. So one of these side lengths is 4.5. Let's make this one 4.5. If anybody can get those exact, then that's pretty cool, because I'm having issues, obviously. Okay, I'm going to zoom out because I need to make a side that's 7. Very close. There we go. I did it. Okay, so I would sketch that on your paper. So there's my first triangle for a side of 4.5 and a side of 7. Now let's make a different one and see if we can make a different one. So let's make this side 4.5, 4.5. No. I'm getting so close. Eek. It's so hard to do this with one hand, but I guess you would just do it with one hand anyway because you're using a mouse. It's probably even harder to do it on your guys' laptops because you don't have a mouse. Okay, close enough. 4.54. Let's make this long side 7. There, 7.01. So there's our second triangle. And it does look a little different from our other one. So that part C, so we've done A, B, and C for 892. So now it says for 893, discuss with your team whether or not knowing only 2 of the possible 6 measurements for the parts of any triangle is enough information to always draw exactly the same triangle. So obviously, we're not going to test more just for, sake of distance learning, but it says what we realized is that we could draw a different triangle for each one of those conditions. We could draw 2 different there, we could draw 2 different there, and 2 different there. So I put for 893, knowing the measures of 2 possible parts of a triangle is not sufficient to assure that everyone will build the same triangle, because that's what we're trying to get at, is we're trying to figure out, well, what 2 parts or what 2 or 3 parts do we need to know in order to all build the same exact triangle. So obviously only knowing 2 possible parts is not enough. Okay, so it's 893. All right, now 894, it says, imagine now that there are 3 possible measures for a triangle 6 parts. So either the 3 angles or the 3 side lengths are given. Do you think everyone will make the same triangle in this case? Okay, we're gonna do the same thing, but with a different, with this E-tool. So our first triangle is going to be, it's giving us the side lengths. of 1.5, 5, and 4.5. So let's see. Hopefully it gives it to me this time. Oh my gosh, it doesn't. Oh well. Okay, so we need a 1.5 side, a 5 centimeter side. Let's start with 1.5. Let's make this guy small. 1.5. Wait, right there. Good. 1.5, I think it was 5 and then 4.5. All right, let's make, since that side's getting bigger anyways, or it's bigger than the other ones, let's see. 4, 5, let's see, 5, 5, 5, 5, 5, 5, 5, right there. And that one's about 4.5. Come on, come on, come on. I almost had it. I almost had it right on the dot. I can do this. I can do this. All right, that's as close as I'm gonna get, but that's our first triangle. So we have a side of 1.5, we almost have a side of 4.5, and we have a side of just about 5. So I would sketch that on your paper. So it's a skinny little triangle right there, and he's pointing up. So let's make a different one. Let's make this side 1.5, and then that's 1.4, close enough. And then this side will be our 5, and that side will be 4.5. Let's see. Oh, very close this time, very close. Come on, get a little bit more. Okay, that is pretty darn close. Okay, so 4.5, 5, and 1.5. So it's another skinny triangle. It looks pretty much the same as that other one. It's just pointing a different direction. So I would conclude that those look like the same triangles to me for this little part, little eye, whatever that is. Okay, let's try the next one. 4.5 centimeters, 5, and 7. Let's go back here. Okay, let's make a 4.5 side first. Oh, we're already at 4.5 there. So let's leave that alone. 5. Let's make, oh, that one's already 5. Let's try to make this one 7. Oh boy. And 7.5. Or no, it's 7. 7's right. 7. Actually, let's make this big side 7 and that side 5. Getting closer, getting closer. Oh, come on. Okay, I think I'm not gonna be able to get close enough. Oh, you know what? If I do this. All right, I'm not gonna be able to get close enough because my fingers are spazzing out. But pretend that's 5, pretend that's 7, and pretend that's 4.5. It worked last week when I did it. All right, so if we did it again, we will get the same exact thing. So I'm not gonna draw another one because it's pretty much the same one. I'll just give that answer to you. But once again, they are the same triangles. So you might be able to guess that this last one, which is the 3 little eyes, 1.5, 4.5, and 7, let's figure out if they are the same. Let's just double check. So far it looks like they will be. Okay, so we have, oh, did it have 2 side lengths? No, it had 3. Oh, geez. Okay, there we go. 1.5, 4.5, and 7. 1.5, let's make this one 1.5. 1.5, did it say 4.5 and 7? Yeah. 4.5, so we obviously need to make this long side the 7. Okay, so if we make this long side 7, oh yeah, there's no way we'd be able to get that down to 4.5. So this is actually not possible. unfortunately. So no triangle can be made with a side of 1.5, 4.5, and 7. It's just impossible. All right, so knowing that, let's go to part B. It says, at this point, what do you think must be true about the sides of a triangle in order to create at least one triangle? So I said, it was kind of hard to figure this one out. It was pretty difficult. But I'll just combine B and C together, but here's what I figured out. And I did try actually 3 other triangles. So the sum, here's what I figured out. The sum of the lengths of the 2 shorter sides must be longer than the longest side to make a triangle. So obviously if we have 3, 6, and 10, I made it on the E-tool, you'll notice that you cannot make a triangle because the 2 shorter sides, 3 and 6, if you add them together, makes 9. So 9 is not longer than the longest side, so you cannot make a triangle. A 4, 5, 6, if you add 4 plus 5, you get 9. 9's longer than 6, so yes, that would make a triangle. And then I tried this one, 2 plus 3 is 5. It's not longer than 6, so no, a triangle cannot be made from that. So it is enough information with 3 side lengths to make only one triangle. However, the 2 shorter sides must add together in order to make and be longer than the longest side in order to actually make a triangle. Okay, that was a lot of information. Let's move on. I think this is the last one. Now investigate the same question for angles. Do you think everyone will make the same triangle when given 3 specific angle measurements? It's the same idea, but this time with angles, so 90, 60, 30. So here we are. Let's make a 90, 60, 30. So I'm going to look at my little, I think making angles are harder. Let's see. If I make angle C30, I want to bring it out. There we go. 35, 36, 30, 30, 30, 30. Close enough. Okay. 90. This needs to be 90, and that needs to be 60. Okay, we're very, very, very close. Oh, wow, I got very close. Zoom out. So we have a 90, 60, 30 triangle. And if we made another one, let's see if we can make another one. Let's make this side the 90. Let's make C the 90. B is almost 60. So we bring this out. So it's like the same triangle, but this one looks, I don't know, it might be a little bigger than the last one we made. So still same shape of triangle, but maybe not the same size, would be my conclusion for that first one. Same shape, different size. 90, 45, 45. Let's try that one. Okay, so we have our 90 degree already, so let's make a 45. Oops. I'm going to bring in the other one. 45 and 45. Let's see. Can we do it? Can we do it? To make it taller. Yes, to make it taller. And we're getting closer, closer. Very close. So that's a very close 45, 45, 90. Now if we did it again, you know, if we follow the same pattern as the last triangle we did, again, it's going to follow the same shape of triangle, but not necessarily the same size. So this triangle could be shrunken up to a really small version of itself, but it would still have the same angles. And I'm not going to do it just for the sake of time, but that's important to know. Let's try this last one, 135, 45, and 60. 135, 145, and 60. Let's make this the big one. So 135, 45, and we're just about there. Oh, but that one got smaller, so let's make it like that. Oh boy, this one doesn't look like it's gonna work. yeah, this one's not going to work because this angle is way too big and I can't make a 45 and a 60-degree angle with it. So it's not possible. We cannot make a triangle with 135, 45, and 60 degrees. So here's my conclusion for part B. We have to be able to have the sum of the angles in our triangle be 180 to actually make a triangle. Because if we did 135 plus 45 plus 60, nope, that's way bigger than 180, so it would not make a triangle. For part C, here's what I put. I put all three angles is not enough information to make a unique triangle. Angles must add to 180. So the angles might make a smaller version of the triangle, but it won't make the exact same triangle as it would if you had the same side lengths. All right, that's it for this lesson. I'll see you in the next one.